Good morning everyone. I am Balmurthy, lecturer in mathematics. Today I am going to take up a small topic from the chapter circles, and the topic name is pole and polar. First let us see the definition, and before going to the definition of pole and polar, let me recall the concept of chord and secant lines. So what is a secant line? So for example, take one circle and P is any point taken external by outside the circle. Through P we can draw secant lines like this. They meet the circle at two different points. So this is A1, this point is A1, and this point is B1, and this is A2 and B2. Like that you can draw as many as you can through the point P. Here the line segments A1, B1, A2, B2 and A3, B3 are called chords of the circle, and A1, A2, A3, B1, B2, B3 are the point of intersections of the secant lines with the circle. Now let us see the definition of pole and polar. The point of intersection of tangents to the circle S is equal to 0, drawn at the extremities of the chords which are passing through a fixed point P lies on the line L is equal to 0. Then the line L is equal to 0 called polar of P with respect to the circle S is equal to 0. The point P is called pole and the line L is pole of the line L is equal to 0 with respect to S is equal to 0. So clearly understand what is given in the definition. The point of intersection of tangents to the circle drawn at the extremities of chords means, for example, take circle. So point of intersection of tangents drawn at the extremities. So this is one secant line. This is one extremity. These are the extremities of the chord. Now what is given in the statement? The point of intersection of tangents drawn at the extremities. So draw the tangents at these extremities. They intersect at some point. Similarly, take some other chord and draw the tangents at the extremities again. This is one tangent, this is another tangent. Now if you see this is the point of intersection of the tangents, and given that the point of intersection of tangents to the circle drawn at the extremities of the chords which are passing through a fixed point lie on one line. So these point of intersections lie on one line. That line is called polar of the point with respect to given circle. Let us see this directly. See here you can find the pole and polar in different cases. Now here let us check the first case. If P lies outside the circle, then the polar is chord of contact of P. So here in the first case we have taken point P outside the circle. So here we have taken the point. Through this secant lines are drawn which meets the circle at A1, B1 and at A2, B2. You can also draw another line also. Now the point of intersection of tangents drawn at the extremities A1, B1 and at A2, B2. So clearly tangents are drawn at the extremities. They meet at the point here, and also other tangents meet at the other point. Like that you can take one more point, one more secant line here, and you can draw the tangents here also. If you observe that all these point of intersections lie on this line is called as the polar of the given point, and this fixed point P is called pole of the line. So this is the first case where point lies outside the circle. Let us see second case. Suppose P lies on the circle. So here we have taken one circle, and P is a point on the circle. So let us take the point P is here. Okay. Now through this point draw the chords. So this is one chord, this is another chord. Like this you can take, and let it be P. PA is one chord and PB is second chord. Now draw the tangents at this point of intersection. So PA is one chord, draw the tangent at these extremities. So P is one extremity, draw the tangent here. A is one extremity, draw the tangent here. They meet at this point. Similarly, Draw the tangent at PB is another chord. Draw the tangent at these points. So draw the tangent at B. At P already tangent is drawn. This is another point of intersection. Similarly, you can take one more chord also. Even if you take the chord here, so draw the tangent. So this also meets the same line. So in this case, again all the point of intersections lie on one line. Therefore, this line is called the polar of the point. So here the observation is this polar is touching the circle also. In the previous case, when the point is taken outside the circle, the polar is passing through the circle. But here we have taken point on the circle only. When the point P is taken on the circle, this is the polar and this is also touching the circle. So in this case, polar becomes a tangent to the circle. And the third case, if P lies inside the circle, then what about the polar? Let us see. So here, if you observe the figure, P is taken inside the circle. Through P, chords are drawn. So this is one chord, this is another chord. Okay. Now at these extremities again tangents are drawn. These tangents meet at this point. And again one more chord is there. Draw the tangents at the extremities. So this is Q and R. So they meet at Q and at R also. So clearly both the points lie on one line. This is also a polar. You can extend this like this. This is also a polar. So in this case we have taken point on the inside the circle, then the polar does not meet the circle. Next, fourth case, the polar of center of circle with respect to the same circle does not exist. So what is this meaning? Take one circle again. So the polars of the center of the circle. See here, in previous two cases we have taken point outside and inside and on the circle also. Now this is the center of the circle. So we have taken the point near the center. So just like previous cases, draw the chords through P. So as P is the center, the chords are nothing but diameters of the circle only. Now take one chord, draw the tangents here. So this is one tangent and this is another tangent drawn at the extremities of the chord. If you observe that both the lines are parallel, so they will never intersect. That's why there is no point of intersection. So in this case, when the point is taken at the center of the circle, polar does not exist to that point with respect to the same circle. Next one, property of this one, polar is always perpendicular to the line joining center and the pole. So let me explain. Polar is always perpendicular to the line joining center and the pole. So this is the circle and this is the center C. So pole is taken here, for example. Now if you find the polar of this point with respect to given circle, that polar is always perpendicular to the line joining center and the pole. How to prove this one? First find the polar of the given point, then find the slope of that polar. Now also find the slope of the line joining C and P. Now we have two slopes, slope of the polar and slope of the line CP. Now clearly you can observe that product of the slopes is equal to -1. Hence they are always perpendicular. One more property, polars of collinear points are always concurrent. So what does it mean? See, for example, for the circle, if you take collinear points, for example, this is circle we have taken and take some collinear points. So for example, A, B, C are points on the line which are collinear. Now you can find the polars of these points. For example, polar of A is passing through is like this, and you can also find the polar of B that also passes like this, and you can also find the polar of C. So clearly, if the points are taken on a single line, then the points are said to be collinear. For those collinear points, the polars are always concurrent. They meet at a single point only. That is about this property. Polars of collinear points are always concurrent. So that's all about pole and polar properties. Let us do one problem on this model, on this concept also. Now find the pole of the line ax plus by plus c is equal to 0 with respect to x square plus y square is equal to r square. Then how to find the pole of the given line? And the problem is given like this. So to find the pole of the given line, first let us take the pole as x1 comma y1. So let px1 comma y1 be the pole. Then find the polar equation of that point. Polar equation is obtained by the equation s1 is equal to 0. Write down equation of s1, xx1 plus yy1 is equal to r square. Take this as equation 1. But already given that the polar of the given point is ax plus by plus c is equal to 0. Take this as equation 2. Now here we have two different equations 1 and 2. Though the equations are different, they are representing the same line. That is the equation of the polar only. When the two equations represent the same line, then the ratio of the coefficients is same. Now comparing the coefficients, we have x1 comma y1 is equal to minus ar square by c minus br square by c. This is the pole of the given polar. So you can remember this procedure and also remember this formula as well. So you can directly use this formula to find the pole. One more example. Find the pole of the line 2x plus 3y minus 25 is equal to 0 with respect to x square plus y square is equal to 25. Here also compare the given line with the line ax plus by plus c is equal to 0. So that you can have a value, b value and c value, or you can also compare with lx plus my plus n is equal to 0. Just now we have derived the formula for pole minus ar square by c minus br square by c. Same formula you can apply here also. Now substitute those values in the formula. You will get the pole as 2 comma 3. Okay, so in this way you can find the pole of the given line. So that's all about pole and polar. Let us meet again in the another session to discuss about the conjugate points and conjugate lines. Bye.